matrices. Okay. Good morning. Welcome to today's session on teaching technical IEB and AP Maths with the Sharp EL-W506T. We've got lots of things planned for you that will cover both AP and technical maths, as well as some of the more basic maths as well. So we've got this calculator which we're going to use, which is the W506T. It's been upgraded. You can see it looks gorgeous. It's got 640 different functions. We're not going to cover all of those today, just because it would take us about 4 hours. But I do want to show you some things that are really relevant to you, and that will hopefully help you in your teaching of maths this year. Then here is a long list of resources. What I will do at the end of the session is in the chat function, I'm just going to put the PowerPoint PDF version into the chat so you can download it from there. Otherwise, I will also send out a link for where you can download it from on Monday or Tuesday, depending on how long it takes me to upload all of the videos for these sessions. Okay. So if you want to use the simulator, this is the link. You can just download it, and I'll show you how to do the download at the end of the session as well. If you haven't used GeoGebra and you're looking for a functions graph application, then GeoGebra is really nice, and it's got so many different applications. They've also got applets now, which you can download, so you can get a specific code for a specific applet, and you can actually have your students download them onto their phones. So it doesn't require a lot of data, which I thought was really cool. So that's on GeoGebra side. It's done by the Nelson Mandela Metropolitan University in, I want to say Eastern Cape, but in PE. So that side of things. Okay. Then, of course, Maths at Sharp has got all of your worksheets. I will start creating AP Maths worksheets this year, along with some more technical maths worksheets. I started teaching extra AP Maths this year as well for grade 10 students. So I'm really enjoying the AP Maths. It's quite different in some regards to standard curriculum. So it's quite exciting. So I'll add some worksheets on there as well, so that you can hopefully use them for revision towards the end of term 1. Then we've got the other nice worksheets website, particularly for FET, is mathwarehouse.com, and you just need to sift through it and take a look at what you need, but normally it's named slightly different or variations of what we call it, so you just need to pay attention and actually look at the maths behind it. I mean, maths is maths. It's a universal language, which is really cool. Then, of course, mathsjourney.com has got grade 7, 8, and 9 worksheets. And then this link here allows you to download the Sharp graphical calculator. So I actually do want to just show you what it looks like. What are you seeing? Okay, great. You're seeing what I'm seeing. So it looks like this. Okay, and then you can just turn it, oh, that you see, that's, I forgot to do that yesterday. You turn it on, and then you can create a graph like that, and then it's clear. So basically, you can then input data, you can create a graph like that, and then you can draw graphs on your calc. It is free, this software. It's not as pretty as GeoGebra, but if you're looking for specifically a graphing calculator that you don't want to pay $2,000 for, then you can just download this one off the internet. It is a free link. Okay, cool. Make sure we're all on the same page here. Then, of course, we've got some basics, which I think it's always good to cover and sort of have an idea of where all the things are on your calculator. So obviously your on button, second function activates your orange functions, your alpha key activates your statistics, your integrals, your memory keys, your constants and conversions. So lots of things for memory. Or for alpha, your mode button, which I'll come back to after this. Your BS button is not what your kids write when they don't know an answer. It means backspace, so it's for deleting stuff. And then, of course, change will just change the way that your answer looks. So you can change it from a mixed fraction to an improper to a decimal and back again as well. And then of course, equals might give you the solution to your expression, but hopefully maths will help solve other world problems as well. So we have 9 different modes on the W506T. So there's normal, which does all of your basic calculations, the stuff that we're used to. Then of course, statistics, and I'll do both standard statistics and then linear regression. And then I'll come back to using the T value, which you do need for AP Maths. Then you've got table mode, and table mode is awesome. I love it. You can do so many great things for teaching with the table mode, which is really awesome. And then of course, complex numbers and equation solver. You've got a matrix function, the vector distribution and drill. I'm not going to cover today. Vector works very similarly to your matrix, except it's a 1 by 2 or 3. Okay, but we don't cover that in Tech or in AP Maths, so I'm not going to worry about it today. So some exciting new functions. We've obviously added the prime factorization button to your calculator, which is awesome. So you can find the prime factors of any number by just typing in that number, pressing equals, and then saying second function and p facts. And then that will give you that. Now, we've all seen that. That's pretty standard. What's great, though, is that we've also added a highest common factor and lowest common multiple function. So let's say, for example, you want the highest common factor of 36 and 42. So you can say 36, then you press second function and 2, and then you type in 42 and you say equals. Now you can add as many numbers to this as you like, as long as you've got space to type it in. So let's say 54 and equals, and we can add another one like so, and you can just keep going. Obviously, we don't need this many numbers, but it is nice to know that you can do it. We also, of course, have the lowest common multiple function as well, which is second function and 3, and that will give you LCM, and then we can type in 42, and again, you can do it with as many numbers as, with as many numbers as you like on the calculator. So we'll just keep doing it over and over for you. It's a really nice function. This is particularly nice when we are looking at teaching algebraic fractions and we want to explain where we get our denominators from and why we multiply by the highest or by the factors across to get your lowest common multiple. So LCM, LCD, same thing. Okay, cool. So that's those. The other thing that I did want to include before I do teacher shortcuts is actually a binary function. So for the technical maths guys, when you're looking at converting decimal numbers to binary, it's quite a short section, but it's nice to know that you have a shortcut available. So you can type in a decimal number, press second function and divide for your binary, and you'll see that it gives you your binary value. Then of course you can do all of your binary calculations on the calculator. Okay, so you can check your answers, and of course you can convert back by saying second function and equals, and then it will give you back your decimal answer as well. Okay, so that's just binary numbers. It's really, really easy to use. In fact, you have 4 options where you can convert from decimal to something else, and you can convert between hexadecimal and binary as well. So hexadecimal is used in programming. So it's actually a 16 base. So you have digits from 0 to 9, and then A, B, C, D, E, and F as well, which is not complicated at all. Anyway, who's judging? So they use that in naming colors in programming. Okay, so the next thing that I want to show you is a shortcut for your teacher class marks. So what we can do is press our fraction button. Then at the top, you put whatever you want to convert your marks to a total out of. So if, for example, we have a test that we've set, it's out of 70, and we want to convert all of those marks into a total out of 100. So in other words, you're looking for the percentages. You would type 100 at the top, press down and type 70 at the bottom. Now, this conversion you can do with any ratio. Okay, so if you had a test out of 70 and you wanted to convert it into CAS out of 20, then instead of writing 100 at the top, you would write 20 instead. Then we say times, and then our next, we put in our first student's mark, which they got 40 out of 74. Okay, we press equals, and it gives us 57 and 1/7. So what we can then do is press change, and we can see it's 57,14. So we can round it off to 57%. For the next student's mark, we can type in their mark. All we do is type in their mark. Don't press anything else, just the mark and equals. And what happens is the calculator remembers that ratio that you created, the 100 over 70, and that you're multiplying, and it does it for you. So it's just a nice shortcut to have. And you can just keep typing in your entire class lists. Oopsie, we've done that one. Marks until you are all done. Coffee is still warm. You can still spend time with your family, and life is wonderful. Okay, and it's particularly nice for those who don't like Excel. Okay, I saw there were a couple of requests for logs as well as I was going through the comments and special requests. So for logs, I just want to show you two things here. So let's just input a log, and then we'll discuss teaching logs as well for the technical maths guys. So there's two versions of the log. There's log with base 10, where you can just type in, and you don't need to type in the base because it assumes it's a base 10. Okay, or you can do a log with a base of your choice. Okay, so that's to get to that second function and your pi button, and then you can make your base, for example, 2 and 8 like that, and equals. Okay, now if you wanted to, for example, teach that when we add logs with the same bases, we actually multiply their numbers, or like answer numbers, for lack of a better word for it. And then you can see that if I did the same thing like this, it would give me the same answer. So that's it's a nice way to teach through proving it. I haven't done an investigation for this, but I probably should. I do have investigations for grade 7, 8, and 9s for exponents and patterns, and something else, algebra, I think. So let me know if you want that. I can send it to you via email. Otherwise, it is available on Maths at Sharp as well. Okay, so let's go through all of these fun conversions between degrees, radians, and gradients. Now, we don't use gradients in South Africa, so it is an option on here, but we won't cover it today as well. Okay, so the first thing to make sure is that your calculator is set in degrees mode if you're converting from degrees to radians. Okay, let's say you have 30 degrees, then you can convert to radians by saying second function and DRG over there. Okay, now you can see it says your calculator is in radians, so all of your calculations will be done in radians, especially your trigonometry. So to change it back, you can just press this button again, or you can do the long way. Sorry, you can do the long way by going through setup, choosing 0, and then choosing 0 for degrees. Now, there's a really nice shortcut that you can do, especially if you know you're going to be converting between degrees and radians quite a lot. We have these magical D1, D2, D3 keys. These are your user-defined keys. Sorry. So you can store into D1 a function that's already on the calculator. So it's basically for functions that have more than two or more button presses. Okay. So now, if I want to convert between 300.2 degrees and I press D1, it will automatically convert that for me. So there are some examples that I wanted to do with you, just to walk you through it. Okay, so the last one is, just want to share it so that you can see both screens. So over here, I want to actually do this one with you. So let's make sure our calculator is in degrees first. So we just press D1. Okay, Then we type this in using our hour, minutes, and seconds button, because it's asking for degrees, minutes, seconds. So like so. And then we would just press D1, and then it will automatically convert it into radians for us. Now, you can also convert from radians back to degrees quite simply. And that, again, you just type it into the calculator. So if we have 16.25, and it's already in radians, I would just press my D1 key twice, and then I would get to degrees. If we have 1.5 radians, so make sure it's in radians, press your D1 key twice, and there's your degree. So it's a really nice, easy way to convert between degrees and radians. Now, following on from this, there's lots of time functions that you can do using your DMS button. So I want to show you those quickly. So the first option on time is to say how many hours is a certain number of minutes. So we can do that by pressing 0 in our hours placeholder, pressing the DMS button, and then typing in your number of minutes. So let's say we have 652 minutes. And then we press equals, and it gives us 10 hours and 52 minutes. If we want to convert that into normal notation or into decimal notation, we can say second function and DMS, and then it will convert it into a whole number fraction for us as well. Now, the other thing that you can do is to do a speed, distance, time calculation. So if, for example, I travel to Cape Town, which is 1,300 kilometers away, and I do an average speed of 114 kilometers per hour, and I press equals, I get 11 and 23 over 57. And even if I change that, I'm not really sure. So I'm going to guess around 11 hours and 20 minutes. Okay. Then what I can do is, again, just convert my decimal notation into my hourly degree notation. I have 11 hours, 24 minutes, and 12 seconds. The last thing that you can do with the time notation is actually to do a Susie train station question. So Susie gets on the train at 9:45. She gets off at 12:30. How long was she on the train for? So we can say 12:30. So we always use our later time first, minus our earlier time. And you just use your DMS button to separate your hours and minutes. If you had seconds, you could then add another button like that to add the seconds. But if you don't have seconds, it's not necessary to have that degree sign there as well. And you'll see that the calculator automatically does everything for you, including the seconds. So if I added seconds here, you would see that it would come up in seconds there as well. Okay, cool. Any questions? And the section is quite diverse, so I'm going to narrow it down a little bit now. All right, fantastic. Okay, so calculus. So the first thing that I want to show you is that you can do integrals, definite integrals on your calculator, not indefinite ones. So it doesn't solve your algebra for you, but it will help you with checking your answers when you have definite integrals. So to get your definite integral, we're going to use the blue alpha key, and it's on top of your open bracket button. And you'll see it has your opening, closing, and your expression spot. So if we start at -3, remember to use the negative sign and not the minus sign. Minus is a function. So if you put it into one of these values, it's going to assume that you want to subtract something from it. And that will create a problem. So you need to use your negative button. Then at the top, we can put 4. And our expression, to make an X, we can just press the RCL button twice. Okay, you can also use L for RCL, but I'm lazy, so I like the shorter version. +7. Okay, I'm just moving the cursor so that you can see what it looks like nicely. And then we can press equals. And there we go. So that's our answer there. And obviously, the more complicated your integral is, it might take the calculator a little bit longer to do. So for example, we did sine of x. You'll see it says busy, and then it will calculate it for you as well. So it just takes slightly longer depending on the type of integral and how much you ask it to do, because it's using its memory. Okay. Then you can also do definite derivatives. So in other words, it's not going to give you an algebraic answer, but it will give you the gradients at that point. So if, for example, we use the same expression, so x squared plus 7, and we want to look for where x is 1. Okay, so we want the gradients at the point x is 1 for the graph x squared plus 7, then we can do it like that. Now, I'm going to show you something really cool, continuing on from this conversation about gradients and stuff and finding that. So we're going to go to table mode. Cool. I just want to move it so you can see my equation. Okay, so we're going to go to table mode by pressing mode and then 2 for table. And what we're going to do is we're going to type in this cubic expression. Okay, so we have x to the power of 3 plus 13x squared, we'll just do the lazy version, plus 34x minus 48. Okay, so there's all of the instructions here for you as well that you can follow along. Now we press equals. In function 2, I'm going to leave it blank for now. And we can just press equals. Let's be lazy, leave our start at 0 and our step at 1 equals equals. And now you can see at 1, we've got 0. And if we scroll down the table, you can see that as x increases, our values for y are increasing really fast. So obviously there's no more answer or no more turning points or x-intercepts here. So we're going to go back up and look in the negative side. So even though we started at 0, you can still scroll up into your negative integer side of things and take a look. Okay, so we're looking for 0. So here we can see x is equal to minus 6. In other words, our factor is x plus 6. And our other factor is x plus 8. So we found all of our factors there as well. All right, now this will only work if you have perfect factors. Okay, so I'll show you another way to find your roots of your cubic equation in the equation solving mode at the end. It is the last thing on the list, but we'll get there. Okay, now what I want to show you, which is really cool, is I'm going to go back to my original equation. So here's function 1, right? And I'm going to then in function 2 put the derivative, in other words, the gradient equation for my cubic function, right? So it's going to be 3x squared plus 26x plus 34, right? So that's just the derivative of this that I've now typed into function 2. Now, if we look at our table and we look at our gradient, as we scroll up, we can see that our gradient just keeps getting steeper and steeper. Okay, and we can see that from our values as well. The values are just increasing really fast. So if I scroll back up, we're looking for where the gradients, which is answer 2, is changing between positive and negative. And it changes somewhere between -1 and -2. So I can see that somewhere over here is a turning point of my graph. Then if I scroll up some more, here I've got another turning point of my graph because I've got from a negative to a positive. So what it's telling me is that this graph looks like that. Okay, from the gradient, we can see that it's positive gradients. Then it changes over here where our x is between -7 and -8, right? And then it changes again over here between -1 and -2. And this gradient is negative and the rest is positive. And so we can see exactly the shape of our graph and what it should look like as well. Cool. Any questions on that one? We happy? Awesome. Okay, fantastic. So complex numbers. So when I started doing my extra maths with this very bright student, the concept of square root of -1, and where we sat and we've told the students, since they could do so, it's that you cannot take the square root of -1, it's not real. Okay, so which is 100% the case, but we've never gone further than explaining that it's not real. So on the calculator, when you try in normal mode or in your normal calculation place to take the square root of -1, what's going to happen is you're going to get an error, right? Because it's not allowed. It's mathematically incorrect, as we've told our students over and over. But the maths geniuses that make life complicated decided that we could create something called a complex number and take the square root of -1 and turn it into the value of I. So in other words, we take -1 out as a factor and we call it I instead of the square root of -1. Okay, so I think it's very important that we spend some time explaining what I is and making sure that they get it, because the rest of everything will not make sense when we do, for example, calculations where we square I. If I say I squared, I'm going to get -1. Why am I getting -1? Because I'm taking square root -1 times square root -1 and cancelling out the square roots because they're squared essentially. And I'm left with what's inside, which is -1. So it's a really quite an important concept for students to make sure that they actually understand I is the square root of -1 and to make sure that they actually get that that's what it is. Okay. Then from there, once they've got that, complex numbers is actually really easy. So it's pretty basic. You can just type in any complex number onto the calculator. So your I value is, or to make an I, you just press the DMS button. You can see underneath it, it's bracketed as I. So it means that I will only be used in your complex mode. You cannot type in I in any other mode on the calculator. Okay, so there's that. And you'll see that your calculator breaks it down into real and imaginary, into separate rows. Okay, now, what's cool is from here, you can convert it into polar coordinates where you have your modulus and your arguments. Catherine shared that with me last night, so thanks, Catherine. So that's your basically your angle of your modulus of your, sorry, I'm having a moment. This is your argument, which is your angle, and this is your hypotenuse, essentially in normal maths terms. That's what it breaks down into. And then, of course, you can also type in any hypotenuse, and we can use second function and this button here to get our argument, or your angle, and type it in like that. And now, if we want to convert it back into rectangular coordinates, we can simply say second function and 9, and then it will break it down into our real and imaginary values as well. Okay, now the last thing that you can do is if you press your math button, you've got the ability to find the conjugate, the argument, the real value, and the imaginary value of anything that you type into the calculator. So if I want the conjugate of 3 minus 2i, so then I would just do it like that. Now, obviously, the conjugate is pretty straightforward and they don't really need a calculator to do it. But if they want to check, it is an option. And of course, you can do any calculations with your complex numbers. So if I wanted to multiply and check that I multiplied correctly, there we go. Now we can check that our answer is correct as well. Awesome. So that's, oopsie, I think I skipped one. Yeah. Everything. Okay. Are we all happy with complex numbers? It's not complex at all. Sorry, that's a terrible pun. But once you understand what the I is, it makes things so much less complicated and easier to deal with as well. Okay, so let's talk graphs. Now, I chose the absolute value graph because it is an AP Maths calculation. So we're going to go into our table mode again, and we're going to type in an absolute graph. Now, to get an absolute graph, you need to press second function and the negative sign. You'll see above it in orange, it says abs. Okay, so we no longer use those the actual sign of the absolute, we write absolute value graph there, just to make it easier to find. And then we can type in x, and let's say +3. And then we can say equals, ignore function 2. And if we go and look at our graph, we can see this side is positive. And on that side, when we go over to the integer side, it's also positive because x is always positive in this graph. So there you go. So it's a really nice, easy way. So what this essentially gives us is a 2 straight line graph starting at 3 that are mirror images of each other around the y-axis. So it's basically making a V shape for you. Okay, then let's talk trigonometry graphs because those are also fun to watch and look at. So with the trig graph, so if you want to clear the function, just press on twice. If you want to go back to it and edit it, just press on once. Okay, so let's do a tan graph. So we can say tan and then press RCL twice for x, press equals, leave function 2 for now. Now for the step, obviously we don't want to do it in steps of 1 because it would take us a long time just to scroll through the table to find the relevant points. So for trig graphs, I usually recommend a step of 15. It's quite a nice size, but it does give you a really good idea of what the graph shape should look like. And you can plot the points along and see. And then, of course, your asymptote actually looks like an asymptote. So there's no confusion there. At 90 degrees, I need to draw a stripy line on the graph. And because your table is unlimited, you can go for as long as you like. You're not going to run out of space. You can go up into the negative sides as well. It's really nice. So there's a really nice way to teach the cast diagram using the table mode, which I did actually discuss in the high school maths video. So if you want to watch that, just scroll across to where we talk about trigonometry. There's a really nice way for solving trig equations. In fact, I do actually want to share that with you. I should have included it into my presentation. So let's just go back here. Yeah, okay. So there's the cast diagram exercise. I'm not going to go through it now, but what I do want to show you is solving for a trig equation. So we have the general and specific solutions. Okay, so basically, obviously, we divided by 3 and we left the sign x plus 30 is equal to a third. We find our reference angle. Okay. Great. Okay. Then from there, we need to deal with the x plus 30. So we know with our cast diagram like that, sign is positive in the all quadrant, which is just basically 0 plus whatever your reference angle is. So that's this line here. And then sign is positive in the second quadrant, which is the 180 minus quadrant. So that's where this one comes from. So with general solutions, if there are any students watching, you need to always have 2 equations. Okay, so that's the important thing. So from here, we get these 2 equations. Okay, so I'm going to go next door. Okay, so for a general solution, this is where we would stop. Okay, now we want to get the specific solution. So what I'm going to do is take my calculator, and in table mode, I'm going to type in function 1, I'm going to type in my first equation, which is 10.53 plus, and then obviously we don't have a k on the calculator, so we use x instead, times 360. And then in my second function, I'm going to put 130.53 degrees plus k, which we'll use as x, times 360. And equals. And then, of course, your step now is 1 because we're substituting integers for k between -1 and -2, depending on the size of the range that you're looking for in your specific solution. Now, we're looking for answers between 30 and 200. So if we look at our table, that answer there is negative. If I look at -1, both of them are very negative. So I'm just, no less negative than the other ones, but they're higher negative values. That sounds atrocious. Anyway, so at 0, we've got negative 10.53, but we've also got 130.53. So that does fit into our specific solution range. So that's our first answer. Then if we scroll down, we can see we've got 349 and 490, which are both higher than 200 degrees. So that doesn't actually fall into our specific solution. And in fact, we only have one specific solution for this calculation between 30 and 200 degrees. So you can see by using the table mode, you've actually made substituting K a little bit easier and less complicated. And it does help to keep everything in order for your students as well, instead of having to lose where you are and redo the calculation over and over again while changing K. The calculator then does the substitution for you, which is really nice as well. Okay, so that's that one. Let's come back here. Cool. Right, so let's talk probability. Any questions on trigonometry? We're all good? All right, fantastic, fantastic. Okay, so there were a lot of requests, and in fact, I got an email this morning from a student who's saying she's struggling with permutations and combinations. So I do want to go through this quickly with you. So with the combinations, it's order doesn't matter. So it's taking a handful of sweets and shoving them in your mouth. You've got 3 sweets in your mouth. You can taste them all, and it doesn't matter which way you put the sweets in. But with the permutation, it does matter. So whether you take 3 sweets out and you eat them, the orange one first, then the blue one, and the green one, or you eat the green one, the blue one, and then the orange one, your order matters. Okay, which means you have, thanks Amelia, that means that your order matters, which means that you have more possible ways in which to line up a set of elements. Okay, by elements, I mean any things that we are drawing from. Okay, so whether it's a classroom of students, that would be 30 elements, or whether it's a bag of marbles, or it's a packet of sweets, or it's cars, those would be your elements as well. Okay, now, given that we know that a permutation has more possible options, right? We can then say, okay, so I have 4 different students, and I have a first, second, and third place. How many different ways can I arrange those 4 students? Okay, so what we're doing is we're doing a permutation because the order does matter. So we're going to use number 6 for permutation. There's your P, so second function and 6. And then how many spaces we have available to put those 3 students, those 4 students in, which is 3. And then we can see that we have 24. Now, if I did the same calculation with the combination, you can see, okay, so I have 4 students and I have 3 items that need to be carried. Okay, so it doesn't matter who carries what item, they all 3 need to be carried. Then I only have 4 possible ways to give my 3 items to my students. Okay, hopefully that makes more sense in terms of the difference between permutations and combinations. I do have a study guide grade 12 chapter on this, so if you want more notes, then please let me know and I'll send it to you. Otherwise, you can download it from Maths Sharp. It's in the grade 12 chapters section under the students side of things as well. Okay, let's do statistics. So much fun. Okay. Awesome. All right, so I just want to share so that you can see my data. So these are the points that we're going to type in. Okay, we're going to use single data first. So we're going to press 1 and then 0 for single data. Then all we do is type in our data values and press equals after each one. Like that. And last one is 93. Okay, once we're happy with our data, we can then press on or change. Either one is fine. Okay, change is nice in that it reverses direction, so you can do either or. Okay, so if we want to go back and change something, so say for example, 30 was incorrect. It should have been 50 instead. Then I can just type in 50 over that 30 and press equals, and the calculator will overwrite the value for you straight away. Okay. When we're done and we're happy with our data, we again press change. Then we say alpha and 8, and we choose 0 for statistics value. And there we go. You've got your number of observations, your average, your standard deviation, which is 16.68, the sum of all of your x's, your minimum, your quartile 1, median, quartile 3, and your maximum value as well. So your 5-number summary is there. Everything is there. It's really, really easy, and you don't need to stress about doing anything else. Now, if you wanted, for example, to find one standard deviation from the mean, you would use number 2 for variable, and you would choose a specific variable. So we're going to start with the mean, and we're 1 standard deviation away. So again, we're going to go to alpha 8 and choose 2 for variable, and choose 4 for our standard deviation. And then we press equals, and it gives us 49 on our low end. And on our upper end, we've got 82.68 as well. So within 1 standard deviation, we have values between 49 and 82. Okay, so that's basically basic univariate statistics or single data statistics. Then of course we come to linear regression. Okay, so for linear regression, we go to mode, we press 1 for stat, and we choose 1 for a plus bx. Okay. Now there's 2 ways to type in your data. You can either type in all of your x's first, go across, go up to the top of y, type in all of your y's, and then hope that you haven't mismatched 1 or 2 of the questions or come short on a y or made a mistake somewhere. So I prefer to do it where you put the coordinate pairing, because actually linear regression is about scatter plots. So these are in a relationship. They need to be paired together. Okay, so to do that, we type in 3, then we press x comma y, type in 7, and press equals, and we've got, you can see the calculator automatically fills in the table for you. So it is actually faster than doing it the x column and then the y column way. Okay, so I'm not going to fill in all of the data. I'm just going to do up to 6. Okay, so there you go. So there's some data for us, and then we're happy with our data, so we press change, and now again we're at our calculation screen. Again, we're going to use alpha and 8, and now you can see there's actually an option at 1. So we press 1 for regression values, and they are all of our regression variables, our y-intercept, our gradients, our correlation coefficient, and our Pearson correlation coefficient as well. Okay, so all of that is there and available for you. So it's really easy. And again, all of your statistics is still there. So you've got all of your averages, standard deviations, minimums, maximums, all of those fun things, and all of the sums where you have x and y together, or x squared, and all of those calculations as well. Okay. Now, the last thing that I want to show you to do with stats is to get the t value for those AP Maths teachers. Okay, so what we're going to do is we're going to have to go back to our stat mode with single data, but now we're going to have a frequency. And what we're doing is we're creating a bell curve, so a histogram. So essentially, we're creating something that looks like that, but obviously in rectangular format. So it's not a perfect bell curve, but it gives us an idea. So what we're doing is we're approximating a bell curve or a normal curve. Okay, so we're going to have 10 and 5 is our first frequency. Again, you can put it in the other way where you type in all the x's and then type in all the y's, but this way is definitely faster. So just preference, it's really up to you. Okay, now I do need to type in all of these values. Otherwise, we're going to have a nice bell curve. So please bear with me. If you want to do it yourself as well. So we've got 40 and 22 equals. Then we've got 50 and 29 equals. We've got 60 and 24. We've got 70 and 19, 80 and 11, and then 90 and 4. So you can see, if you look at the frequencies, they sort of go up and then come down again. Okay, so once we're happy with this data, again, we can press our on or our change. And then if you look at the actual manual, this is the first time that I've used it, but if you look at the picture, you can see the various options for your curve and what you're actually finding when you're looking for P, Q, and R. So it's the probability of X being at the T here. So anywhere on that bell curve that's less than T, okay, where Q is, it's between 0 and the probability of your X value. Okay, and then R is greater than your T value. Okay, so what we do is, just so you can see the steps. So once we're done and we've pressed on, let's say, for example, we want to find the probability that X lies within the curve. Okay, so we're going to press math, and we're going to choose 1 for our P value, and then 67 is our X value. Then we press math and 0, so whether 67 is the T value, and equals, and now we get a probability that it's within the bell curve, and less than that is 0.81. So it's a pretty strong probability that it's in that bell curve. Okay, so that's T values and all of the fun things that go with it as well. So let's talk finance. Any questions with probability and statistics? We're all good and happy. All right, fantastic. Okay, so I didn't include simple and compound interest for the positive simple and compound interest, for the simple reason that it's basically repeating the decay. So I'm just going to use the decay version for you, and it works exactly the same. So say, for example, our initial amount is 1,000 Rand, and we are decaying at a rate of 5% per year with simple interest. Okay, so there's my formula. Okay, then we say equals, and I'm going to leave function 2 for now, and let's just work through this first one. So X is my number of years, and this is what I am losing every year. So every year, the value of my item, whatever it is, call it a pot, is worth 50 Rand less than it was the previous year. Okay, so now I'm going to leave this simple decay here, and I'm in function 2, I'm going to type in a compound decay equation. So I have 1 minus 5 over 100 to the power of, and then I'm going to put in X. Okay, so from there, again, we can scroll through the table, and we can see in year 1, they lost exactly the same amount because they both lost 5%. But in year 2, we're losing 5% of the previous value, whereas with simple decay, we're losing 5% of the initial value. So with simple decay, we can see that at a certain point, our item is going to be considered worthless. But with compound decay, we can see that our item will never actually be completely worthless. It will always have a value. It will just head to 0. And you can see again from the table, you can take as long as you like, and you're not going to run out of space here. So it's a really fun way to teach finance as well. Now, what's really cool is I want to show you a present value annuity. Okay, so I've used a present value annuity just because it's an interesting story. You can do this with both finance as well as with with future values as well. So both of them are a good option, and there's lots of different ways to explore future values and present values. But what I want to talk to you today is with regards to your monthly repayments and what sort of size loan you could get. Okay, so I'm not going to give an amount for my monthly repayments. I'm simply going to use X. Then the rest of the formula is pretty straightforward. We're going to do an interest rate of 10%, compounded monthly. Okay. And we're going to borrow the money over a period of 5 years. Okay. And obviously pay it monthly. And then it's just my interest rates again, compounded monthly as well. Okay, so I know I did this really fast. I'm good at this. I use the calculator a lot, but the steps are all here for you. So when you want to go and explore it yourself, you can definitely do that. Okay, so let's delete that decay. So just to delete a function, just press your on button. Again, we can leave start and step at 1, and I'm being silly by leaving my step at 1, but I do want to make a point. Okay, so what this table is actually saying is that if I'm willing to pay back R1 a month for the next 5 years, I can right now borrow 47 Rand. If I'm willing to pay back R2, I can borrow 94 Rand. Okay, and so on and so forth. So we can see that this is going to take us a long time to get to anything relevant. So what I'm going to do is in my step, I'm going to change it to steps of 100. Okay, and then now if I'm willing to pay back 100 Rand a month, I can now borrow 4,700 Rand. So if I can afford to pay 1,000 Rand a month for a car, I can only borrow 47,000 Rand. If I want a car that is worth 100,000 Rand, I go look for where it's approximately 100,000 Rand, and I can see that I'm going to pay back between 2,100 and 2,200 Rand for that car. Okay, so you can calculate essentially affordability. So if my budget is 2,500 Rand a month, I can buy a car that's worth 117,000 Rand and change. Okay, so it's a really nice way to look through what a present value annuity is. So it's what you can loan and what you can afford to repay based on your interest rate. Now, of course, you can go and tweak this. So if, for example, we wanted to buy a house, we can buy a house over 20 years and our interest rate hopefully is lower. So I'm going to change it to, let's make it 8%, right? Aren't these buttons magical? 8%, and then we'll just scroll through. So if I want to buy a house for R1 million, we've got to go find where R1 million is. Just scroll through the table until we get there. This took longer than I planned. Nearly, there we go, there's R1 million. So it would cost us 8,400 Rand a month at a rate of 8% per year compounded monthly, and it would be over 20 years with monthly repayments. And you can see that that's the amount that you would be able to loan for. Okay, so that's present value annuities and all of the fun things that you can do with it. We happy? We don't have questions there? Okay, awesome. Let's move on to matrices. Why haven't I done that? So this is for the AP Maths, guys. We don't cover matrices in technical maths. So what I want to show you now is some really nice tricks for this. Okay, so let me come back here. So we need to go to our matrix mode, and to do that we press mode, and it's option number 5 on our mode menu. Now we want to input this matrix over here. Okay, so to do that, we press math and we choose 1 for edit. Okay, and this is a matrix of size 3 by 3. Now your calculator can do matrices up to the size of 4 by 4, and you can change them into non-symmetrical matrices. It's up to you. So once you've selected the size that you're happy with, you just press equals. I've just chosen a 3 by 3 because it fits nicely into the calculator screen and you can see the whole thing. So we've got 3, and then it goes across in columns, across in rows, and then down as well. So we've got 7, and then -2, and then 8, -7, 4, 1, 0. I can just skip by pressing equals and it'll just save the 0. So instead of having to type 0 again, 5 and equals there. Okay, once you've typed in your matrix, you press on and you save your matrix into, you store it into a matrix name. So we can call it matrix A, which is 0. Now, if we want to do any calculations with the matrix, right, we would have to then go into math, call the matrix by pressing 0, 0. And then let's say we want to find the inverse. So where's my inverse? There it is there. And we say equals, and that will give us our inverse matrix. So really easy to do. Okay. But there is a shorter way to do this, and that's to store the name of the matrix into our D1 key or D2 or D3 key. Okay. So what we do is press math, choose 0, and then choose 0 again. Now, whenever we press D1, it's now got the matrix A saved into it, and then we can then do calculations with it as well. You can also find your determinant. That's option number 4. So we would press 4 of determinant of matrix A and equals, and there we go. You can also do the transpose, which is option 5. So of matrix A and equals. We've even got a row echelon form, okay, which basically means that it reduces the matrix to your main diagonal being 1s and anything below that being 0s. You've got an identity matrix. So if you wanted to create an identity matrix, you could just press 6 and tell them how big you wanted it to be. Okay. You've got a random matrix, and then of course you've got your row echelon form, but that's what ref stands for. So we would press the A button, and then you type in the name of your matrix and press equals. And you can see there, it's done all the calculations for you. So it does save a lot of time, and it's really nice for checking as well. So the other thing that is added is we've got a reduced row echelon form. Okay. And so I want to do a different matrix for this, because otherwise you would basically get just 1, 0. You would get an identity matrix if your matrix was a 3 by 3. I'll show you in fact. So if we did, so our reduced row echelon form is B. So if I pressed B and then chose our matrix A, which is a 3 by 3, you'll see that it just gives you an identity matrix. So what I want to do is edit a matrix as a 2 by 3. Okay, then I'll have 3. Let me just show you my screen so that you can see where I'm getting this from. So I'm using this matrix here. So it's 3, 6, minus 2, and 1, 7, and 8. So this, we use this in solving a system of linear equations. Okay. So once that's done, we can press on and we can store that matrix into matrix B, just for fun. Okay. And then we would then have to say math and B for our row echelon form, and then math, and we'd call our matrix with 1. And there we go. So you can see this part is the identity matrix, and there's your solution to X and your solution to Y. Okay. Cool. Happy? I think equations is the last section, so we should be all good. It shouldn't take too much longer. Okay, so I'm going to do 2 examples with you in equation mode. I'm going to do the 2 variable linear equation, and then I'm going to do a cubic equation with you as well. So let me just share it so you can see both. So here we're going to press mode, and we're going to choose 4 for equation, and then you've got 4 options. So you've got 2 variable linear equations, 3 variable linear equations. In other words, it's just x plus y, so straight line graphs, or x plus y plus z for the 3 variable. Then you've got a quadratic equation, which is ax squared plus bx plus c. And then you've got a cubic equation, which is ax cubed plus bx squared plus cx plus d. Okay, so let's do a 2 variable linear equation. Now you can see, here's my example, 3x plus 7y is equal to 9, and negative 4x plus 12y is equal to 5. So we're going to just type in those values for in front of the various numbers, like that. And 12 and 5 and equals, and there's our solution. The D stands for your determinants of that matrix. Okay. Then if we wanted to do a cubic equation, so there's the format there. Let me just, cool. So here's our example, 7x cubed minus 3x squared plus 8x minus 12. So we would press mode, choose 4 for equation and 3 for a cubic. And then in A, we would type in 7. In B, we would type in -3. In C, it would be 8. And in D, it would be -12 and equals. And we can see that we've only got one real solution, and then we've got a complex value solution as well, which is that I. So it's given it to you in parts real and imaginary. Okay. Awesome. Guys, that is the end of this session. I do appreciate your time. And if you enjoyed this video, please like and subscribe it on our YouTube channel.